Monster Laboratory here. I just wanted to share with you guys that I finally got the Raspberry Pi Pico microcontroller. After hearing all the wonderful things about it, I'm a little late to the dance, but I finally got one. Today we're going to take a real quick look at what this microcontroller has to offer. We're going to install Thonny Python IDE. We're going to add the MicroPython firmware. We're going to blink an onboard LED as well as a 5mm LED using a couple of the GPIO pins. I purchased this board with the header pins soldered in place so I could use it right out of the box. And it's powered by a micro USB cable which you can plug directly into your computer. Here's the Raspberry Pi Pico datasheet. Here's a look at the Raspberry Pi Pico on the front and back. We see that it uses the RP2040 microcontroller chip with 2MB flash. It also has quite a number of 3.3 volt GPIO pins, and it uses the dual core Cortex M0 Plus up to 133 MHz. It also has other peripherals including UART capability, I2C connection, SPI connection, PWM channels, as well a timer with alarms and a real-time counter, as well as some other programmable options. Some of you may be happy to know that Raspberry Pi Pico supports MicroPython and C++ programming languages. Here's the pinout, and as you can see, it does have a ton of options. Now it's time to get this thing up and running. As you can see, I've seated my microcontroller into the breadboard here. Now it's time to go to thonny.org to install the Python IDE on my Windows computer. And as you can see, you can put it on Windows, Mac, and Linux. So we're just going to download it for Windows. So it downloaded as a zip file. I unzipped it, installed it on my computer, put an icon on the desktop, and opened it up. Now it's time to connect the board to the computer using the micro USB cable. Before I plug the other end into the computer, I want to press and hold the boot select button on the board. After that, we're going to switch over to the Thonny IDE screen. Now you're going to get a window pop up, and that is the storage to your Pico board. In there you're going to see an info document, and that can help you if you have any issues trying to set your board up. Go down here and click on Python, and then click on MicroPython Raspberry Pi Pico. Go ahead and click on the option to install the MicroPython firmware. After you're done installing, go ahead and close that out. If you look down at the bottom right of your screen, you'll see that it is now operating in MicroPython Raspberry Pi Pico. And that is what you want. If the install was successful in the shell, you should see MicroPython in the latest version. Now that Thonny can connect directly to our Pico board, we'll go ahead and type in a command in the shell and let it run on the Pico. Now I'll type in another command in the shell. We're going to start with from machine import pin, and we'll do that to create an object that corresponds with the onboard LED so that we can light it up. And we can access this LED by using GPIO pin 25. Assigning a value of 1 to the LED value will turn the LED on. And if we flip over to the camera, we can see that the onboard LED is lit up. Now if we assign a 0 to the LED value, that LED should be shut off. And if we switch over to the camera, we see that the LED is off. And I'll go ahead and show you both screens, and I'll turn the LED back on here. If I assign a 1 to it, it should turn back on. There we go. Typing your code into the shell is like using an interactive console for single commands or just making sure that everything works. But if you want to type out longer code, you want to do it up here at the top so we can save it. You can't save code from the shell. So in the top part here, we're going to type out similar code. We're going to use the timer so that we can toggle the light on and off without having to do it manually. And if you're like me, you always have at least one typo in your code which you have to go back and find. So once we find it and we fix it, the light will toggle on and off. There we go, now it's working. Now when it's time to save your file, it'll ask you where to save it. You want to save it to your Pico board. And be sure to use the .py file extension so that Thonny recognizes this file as a Python file. Now the last thing we want to do is blink an LED on the breadboard. So we're going to go ahead and add a 5mm LED to the breadboard. We're going to connect the positive pin of that LED to pin 15 on the Pico by way of a 180 ohm resistor. Now you can use a 50 ohm to 300 ohm resistor, doesn't really matter. The negative leg, or the negative pin of that LED, we're going to connect to a ground pin on the Pico. Since the GPIO pins are labeled on the bottom of the board and we can't see it, we're going to go ahead and take a look at the Pico pinout sheet and locate pins 15 and a ground pin. I've located my ground pin. I'll go ahead and connect it to the LED. My resistor is already attached to pin 15 of the Pico board. Since we're going to use the same code, all I need to do is change it from pin 25 to 15 and then hit run script. Now that our LED is blinking successfully, we have completed our first Raspberry Pi Pico exercise. Definitely come back and check out some more projects we're going to do with this board. Thank you very much for watching. Don't forget to subscribe, and I will see you again very soon.